All right. So let's see if we can figure out what these directions mean. On page 36, number 7. So, page 36, number 7 says, our job is to find the sine and the cotangent. That's all we need. You don't need to find the whole list like you did on yesterday's quiz. You just need to find the sine and the cotangent. Now, what do we know? What we know is that the cosine is 2/3 and the tangent is a negative number. This means less than 0 means negative. Now, what this is doing for you is helping you figure out what quadrant you're going to draw your triangle. You are going to draw a triangle. And in that triangle, the adjacent side is going to be 2, and the hypotenuse is going to be 3. Your first instinct, and I'm with you, your first instinct is to draw this triangle. Doesn't that have a cosine of 2/3? But it doesn't have a negative tangent. So you have to think about, okay, I gotta draw that triangle in a different quadrant. But I still need this to be positive. So somebody said quadrant 2. Let's take a look at it and see. If I drew this triangle in quadrant 2, would the cosine be 2/3?
No.
No, it would be negative 2/3, wouldn't it?
Quadrant 4.
Quadrant 4. Let's try quadrant 4.
Is there an easier way of doing this?
If I drew it in quadrant 4, would the cosine be a positive 2/3? Yes? Would the tangent be a negative number? Yes, because when I haven't figured this out yet, but when I figure this out, won't the tangent end up being negative? So that's the triangle we want. Now somebody over here says, oh my gosh, isn't there an easier way to do this? Yes, but you gotta have your thinking caps on. Cosine is x over r, right? And r is always positive. So if this is going to be positive, doesn't that mean your x coordinate has to be positive? So now this tells me my x has to be positive. Now tangent's y over x. If I already know x has to be positive, but this has to be negative, then doesn't y have to be negative? So I'm just going to ask myself, where is x positive and y negative? That only happens in quadrant 4. So all that's shuffling around in here. All right, so anyhow, that's our picture. Any idea what I'll have to do first? Pythagorean Theorem?
Yeah.
So 2 squared plus y squared is 3 squared. 4 plus y squared is 9, y squared is 5. What is my y? Negative root 5. So what's my sine? Here's your angle. What's my sine? Opposite over hypotenuse, or y over r. What's my cotangent? X over y, or adjacent over opposite. So we got a radical in the bottom, so we're going to pull that to the top and make a plane 5 in the bottom. There we go. Tricky stuff. All right, let's try the next one. Is there another one?
On the back.
All right, so we're going to find the secant and the tangent. So our job is to find the secant and the tangent. All right, now what do we know? Let's start thinking about this. We know the sine is positive. So what'd you say, Schlebecker? Y is positive. Does that make sense to you? If the sine is a positive number, then that means y has to be positive. Remember, r is always positive, so it's not part of the conversation. If the sine is positive, that means y is positive. I'll make a little note here. Y is positive. Now, the cosine is negative. Now, what does that mean? If the cosine is negative, then x has to be negative. Cosine is x. So where am I going to draw my triangle if the y has to be positive and the x has to be negative? Second quadrant. And the sine was 1/5. So all this junk right here, guys, is helping me figure out where to draw the triangle. And then once I draw it, I have to make it so the sine is 1/5. Not root 26. Not root 26. No, 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 no. 1 squared plus x squared equals 5 squared, right? When we do the Pythagorean Theorem, we have to have it equal to the hypotenuse.
24 squared.
So x squared equals 24. So the square root of 24 is 2 root 6. Negative 2 root 6. Everybody get why I put that negative in there? X is negative. We're left. Okay, so I need the secant. Oh, what's the secant? Hypotenuse over adjacent. Now we're going to move the radical to the top. And this turns into a plane 6. So on the bottom I have a 12.
Yeah.
Tangent. 1 over negative 2 root 6. So we'll move the radical to the top. That becomes a plane 6. So that's a negative 12. Ay, ay, ay. These are hard. What? All right, one more. We got to find the tangent and the cosecant. And we know the cosine is negative 3/5 and the tangent is positive.
It's going to be negative.
So x over r is cosine. So x is negative. So we know x is negative. Now the tangent is positive. Okay, now think about this, you guys. Tangent's y over x. We already know x is negative. So if that's going to turn out to be positive, doesn't y have to be negative also? We already know x is a negative number. If that fraction's going to be positive, then y has to be negative also. What? So that happens in quadrant 3. So I have a triangle in quadrant 3. The cosine is negative 3/5. So I'll do my Pythagorean theorem. Carefully. Uh, 3 squared plus y squared is 5 squared. Notice I dropped the negative because I'm squaring it. I don't want to confuse myself. I got 4 negative.
That's what I got.
What's tangent? Tangent is negative 4 over negative 3, which is positive 4/3. Remember, there's your angle, so opposite over adjacent. What's the cosecant? So negative 5/4.
Yeah.
Okay, now that's not on the quiz. What's the quiz? One's like n part 5 and 6. Okay, so we have one more thing to do. One more thing. We are going to sketch one period of the sine. So this, we're only going to do A. We're going to sketch one period of the sine. You have no idea what I'm talking about.
I got you.
The sine curve is a series of waves. It goes on forever and ever and ever and ever, but we're not going to graph it forever and ever. We're only going to graph one piece of it. Those are called, the pieces are called periods. We're going to graph one period of it. Here's what I want you to do. On your axis system, I want you to put a 90, a 180, a 270, and a 360 on the x-axis. Now, you may not know why I'm using those numbers, but you absolutely are comfortable with those numbers. When I'm drawing my circle, it's once around. So those are the ones I'm using, the quadrantal angles. On the y-axis, it's 1 and negative 1. Now, this is important, so please make sure you're drawing this, because on the whole next page, you're going to be doing modifications of this. So I want to make sure that you get your base curve correct.
That's going to be for all of them?
Yes. So this, well, until we start putting in extra numbers and then things change. But for the basics, yes. Now for sine, we're all graphing the sine. I want you to put a dot right here at the origin. Then I want you to put a dot right here. So look where I put it. I went over 90 and up 1. Make sure you're getting that in the right spot. Then I want you to put one right here on the 180. And then I want you to put one down here under the 270. Down 1 from the 270. And then put one at 360. That's where your dots need to be. Huh? Well, for a sine, until we start putting numbers in, and then we're going to do what we did before. We're going to stretch it, shrink it, move it, and all that. But this is the basic curve. Now, I want you to connect those dots with a nice, smooth curve. Do not do this kind of stuff. No, no, no. A nice, smooth curve. And that is your very first sine curve. All right, we're going to go ahead and get the cosine done too. I thought we ended at 40, we ended at 50, so we got a few more minutes. So basically, I lied to you when I told you we were going to finish with this. We're going to go ahead and do the cosine also, but that's your sine. Please make sure that is accurate on your paper. Because if you don't know this basic shape, you won't be able to do the next page. Okay. Now, cosine. Set up exactly the same way as you have already asked. So 90, 180, 270, 360, 1, and negative 1. Your first dot for the cosine goes here. Notice it's in a different place. You have to memorize it. Now, I have a little hint for you. A lot of people think this is stupid, but it's how I remember it. Good Catholic girl, I remember original sin. Sine goes through the origin. The sine goes through the origin. The cosine does not. Now the cosine follows the same pattern though. So I'm going to put a dot here. Your next dot's going to go here. Your next dot's going to go down here. Up here. Up here. So there are my dots. Now when I connect those with nice, smooth curves, you're going to think that looks weird. But I want to remind you that these things go on forever and ever. So if I were to continue it, do you see the waves in there? It's just this particular piece of it goes from the top of the hill to the top of the next hill. Now, these two curves have period and amplitude. I'm not going to write those words out each time. So period and amplitude. What we mean by period is from start to finish. Now, you're thinking to yourself, Mrs. Ford, you just told me this thing doesn't end. It doesn't. But after I draw one hill and one valley, what would I draw next? Another hill and another valley. And then another hill and another valley. So the period is kind of like the piece that keeps repeating itself. So a hill and a valley, and then another hill and valley, another hill and valley. So the distance to get one hill and one valley done is 360 degrees. Which just so happens to be one time around the circle. Does it make sense to you that if we went around again, we just repeat and repeat and repeat? So one period is one revolution. Amplitude, by definition, is half the distance from the top to the bottom. I think we've talked about that before. But for the sine and cosine, it's just the height of the hills. How high is that hill? Your amplitude is 1. Now look at my cosine. Will the period and the amplitude for the cosine be the same?
Yeah.
Yeah. These two are the same curve. You're just looking at a different chunk of it. It's shifted. But they're the same curve. They're the same characteristics. Okay, so everybody has your sine curve drawn and your cosine curve drawn, right? Because now we're going to do the tangent, which is completely different.
Yeah.
And the tangent is different because it can be undefined. Okay, this is the last one, I promise, huh? Well, we start, okay, let's go ahead and put our 90 and our 180 and our 270 and our 360 on here. But I'm going to ask you to go one back this time and also do negative 90. Does that make sense to you? If we went this way, that would be negative 90. Now, your tangent curve has an asymptote at negative 90. That's why I wanted you to put that in there. and an asymptote at positive 90. It looks like your cubing function. Remember that cubing function, that squiggly line? Remember that? That's what a tangent looks like.
Cool.
Oh,
That's a tangent.
okay.
Now, that's all you have to draw. That's it. Because if you drew more, it would just be more of these squiggly lines. So, for example, there's an asymptote over here, and it looks like this. That's exactly the same as this. So I'm never going to ask you to draw more than one squiggly line. You're going to draw one. So we don't need all this other stuff. Now wait. What is the period and the amplitude of the tangent? What? 180. The period is 180. Because asymptote to asymptote is 180. What'd you say?
Yeah, you bet your ass.
Okay, amplitude, actually we don't say undefined, we say the word none. There is no amplitude, because amplitude is half the distance from the top to the bottom. Do tangents have tops or bottoms? No, so there is no
Yeah, you
amplitude.
bet your ass is dope.
You bet your ass is toast. That's right. Oh shoot, that's on video. I'll probably, if I'm not here tomorrow, you'll know why. The